Right, so for this question, we're going to take a look at the graph in particular. Specifically, this x-axis is the volume of solution X added to Y. Okay, and then on this side we have the pH. Okay, so basically we're trying to find out when neutralization happened. Okay, so really what this comes down to is finding out what the pH, when the pH hit 7. Okay, so 7 is up here, 0, 2, 3, 4, 5, 6, 7. Okay, and we started with a basic solution because the pH was between 10 and 12 here. Okay, and so we've added 10 milliliters of, I'm assuming some acid. Okay, and then it starts to go down here. So it's, neutralization is starting to happen here. So when does it hit the 7? Okay, that's what we're looking for. So if we draw an imaginary line or use a ruler to find out what the volume of solution is here, okay, we'll see that it's 24. Okay, 20 is still at 10, still basic. 20, or what's that, 10, definitely still basic. And 44 is an acid at this point. Okay, so that's not those ones. Okay, next question. The pH of a variety of solutions. As I mentioned in the lessons, you basically have to memorize which ones are acids and which ones are bases, okay, to help you with these questions. So that, yes, of course, we should look at the graph, but we should also have it in our head what's acidic and what's basic. Okay, so our vinegar, our lemon juice, and our apple juice are strongest acids on this list. And it makes sense because it matches with the bar graph. And this is pH on this side. Okay, and ammonia, lye, baking soda are our strongest bases. Okay, and quite often we'll neutralize vinegar and baking soda, right? We do that experiment and mix them together, and we get the production of a gas. So really what you want to do with this question is figure out which one is false. Okay, so 3 of them should be true. 1 of them should be false. So let's take a look. Tomato juice is less basic than vinegar. Okay, so tomato juice, it doesn't matter how far it is on the right and left here. It matters how high it is here. Okay, so tomato juice is less basic. Okay, less basic, more acidic than vinegar. No, it's more. This is tricky, right? Let's look at it carefully. Tomato juice is less basic than vinegar. Tomato juice is more acidic than vinegar. No, it isn't. Okay, so A. Let's double check though to make sure that it's A. Lye is the most basic of all solutions. Yeah. Apple juice is less acidic than lemon juice. Apple juice is less acidic than lemon juice. True. Human blood is more acidic than ammonia. Human blood is more acidic than ammonia. True. Okay, so A. Yeah, they're kind of being mean with their less basic and incorrect, but that's how it goes. Okay, here's another acid-base one. Okay, let's take a second to read it. Pause perhaps, try it on your own. Okay, so in this question, we're trying to figure out what a responding variable is. Manipulated variable is the thing you change. Responding variable is what happens because of what you changed. And controlled variable is what you leave the same, so that your experiment makes sense. You can't change too many things, otherwise it's an invalid experiment. Okay, so in this case, you combine 60 milliliters of vinegar with antacid. Okay, so how much vinegar is probably what the experiment's about here. Okay, and after 10 minutes, you measure the pH. So you're checking to see the pH. So that's going to be our responding variable. Let's check and see if that's in our list. Okay, pH is vinegar. Oh, good. Okay, so let's examine what the other answers are. Type of antacid should be the same in each one. Okay, but that's what they're changing. So they're measuring vinegar being the same in each one. And then what antacid they use each time. That's what they've changed. Okay, so the manipulated variable here is the antacid, and volume of vinegar in the solution, they are using 60 each time, so that's a controlled variable, and then length of time waited before you measure is the same, right? So 10 minutes each time, 60 milliliters each time, those are your controlled variables to make sure your question is valid. Next one, WHIM symbol, biohazard. Okay, let's see. What does it say? How to safely deal with the material. Place it in a biohazardous waste bin. Yep, good idea. Dilute it with water. Nope, that would be like the environmental one probably. Combine it with the sand gravel mixture before disposing of it. Nope. Place it in a lead-lined container for radioactive waste. Nope, that would be a radioactive one. Okay, so the top one. Let's take a look. Are these ionic or molecular compounds? So an ionic compound is one where you have a metal and a non-metal. So let's take a look at our periodic table, which we happen to have handy. Carbon, right-hand side. Hydrogen's technically on the left-hand side, but it's a non-metal, right? It's usually a different color. And the top left to help you remember that it's a gas and that it's even though it gives away an electron and becomes positively charged, that makes molecular compounds. So these two are molecular. So it's not these questions. Okay, this one for sure is not ionic because nitrogen and oxygen are both nonmetals. Okay, so I would cross that out if I had this on paper. Okay, and then this one too, cross that one out because it has nitrous oxide in it. Okay, or officially it would be nitrogen dioxide, right, if we're naming it properly. Okay, and this would be hexacarbon hexahydride. Okay, so it's got to either be this one with lithium chloride and beryllium fluoride. So yeah, it's going to have to be that one. Okay, because we crossed out the other two. So this is a metal and a non-metal. Metal and a non-metal, we're good. So that's ionic, C. Down here we see a copper precipitate formed. So like the chunkies when you pour vinegar and milk together. Okay. So it appears in a solution of copper sulfate, copper 2 sulfate. This is what it is right there. Okay, but the formula after a piece of zinc was added to the solution. So they're being nice here and saying what zinc is and what copper sulfate is. So you're just trying to write out the equation based on the words. Okay, so they see a copper precipitate. That's what's produced. So that needs to be on the product side. Okay, these are reactants, these are products. And this isn't math, so there's no equals. Okay, this is reacts to form. Okay, so copper needs to be on this side. Okay, so it's definitely not B. Let's cross that out. Okay, appears in a solution of copper 2 sulfate after you add zinc. Okay, so zinc can't be on the right-hand side. Let's cross that out. Okay, and you're going to need to cross out this one as well because zinc is on that side. So it has to either be C or D. Now let's go back in and check. It says we have zinc on the reactant side and we're adding it to copper sulfate. So copper sulfate needs to be on this side. Okay, so we're going to go with D. And that makes zinc sulfate. Okay, next one here. They're kind of expecting you to know what water looks like, H2O, right? So hydrogen is the smaller atom, oxygen is the bigger gray one. Okay, so with water, we have these here. Okay, molecules of water, H2O. Okay, this would be 2 O's and an H. These ones aren't even connected, so that's not a molecule. Okay, this is missing. This would be HO. Okay, so that's just not right. So they're assuming you know H2O is water. Okay, let's take a look what washing soda is. Na2CO3. What is that? Sodium carbonate? Yeah. Bicarbonate, maybe? I'd have to look it up. Okay, so in what elements do we have? Na for sodium, not nitrogen. Nitrogen's N. Okay, C is for carbon, not calcium. Okay, so carbon. And then O is for oxygen. So oxygen is on the list for sure. So the one that says sodium, carbon, and oxygen is C. Which group of elements on the periodic table has the least reactive elements? Okay, and that's the noble gases, which is group 18 on the far right-hand side. I should give more time in between reading the question. Make sure you pause it, so you can try it on your own self. This is very common to see questions like that where they just highlight certain elements on the periodic table. Okay, so let's take a look. We have potassium, iron, copper, silver, and mercury. Okay, so which of the elements on the periodic table would be another appropriate metal to use for producing metal coins based on its similar properties to copper? Okay, so copper is going to have similar properties to silver. So that's probably the answer, but let's look. Okay, copper has been used to produce metal coins because it's not reactive with most acids. Okay, not readily reactive with oxygen. All right, malleable. Yeah, so basically they're just asking which ones are going to have the most similar properties, right? So really different from potassium, it's way over here. Okay, and mercury would be the next closest, and iron would be the next closest. But silver is right in the same line here, the same column. Okay, so they're going to have similar properties. This is probably a conservation of mass question, just because there's numbers, so let's take a look. In an experiment, 12 grams of solid carbon reacted with oxygen to make carbon dioxide. So what I would actually do is write it down. I'd put O2 plus carbon, solid, reacts to form an arrow, CO2 gas. Okay, so you put 12 grams on this side, 44 grams on this side. Okay, so you're going to subtract them, right? Because what's on the left-hand side has to equal what's on the right-hand side. So 44 minus 12, the math, B, 32. All right, in this graph, you have what's going on in terms of corrosion, right? Rust, you add oxygen, and you get something like iron oxide. Exothermic releases heat. Combustion is burning, so you add oxygen, and you get usually carbon dioxide, water vapor. And endothermic is taking in heat. So let's take a look. Okay, this y-axis has temperature, so it goes 10, 5, 10, 15, 20. Okay, 0, 0, 5, 10, 15, 20, and a minus. So you start with your solution at about 14 degrees Celsius, and you see that the temperature has decreased over time. Okay, so we're looking at an endothermic reaction here. All right, let's take a look at this one. Element, compound, solution, mixture. So out of our classification of matter chart, where we had pure substances and mixtures, okay, that's what we're looking at here. So acid rain, you can't tell that it's a bunch of different materials together, so we're going to go with solution. Chocolate chip cookies, mechanical. Helium gas element. Table salt, NaCl, is compound. Okay, so it's going to go 3, 4, 1, 2. Okay, so looking at which one is a chemical property. Density is physical. Melting point, physical. Microscope shows the crystal structure, that's physical. And what happens when you react with an acid, that's chemical property. Okay, so test D. In this one, we have statements about the pH scale. So which ones are true? Which ones are correct? Acids have lower pH than bases. True. Bases are at the beginning of the pH scale, starting at 1. False. Neutral is 7. True. Weak bases have the highest pH. No, that'd be strong bases. Okay, so 1 and 3 are the right answers. 1 and 3 are the right answers. That's A. All right, so let's take a look. Keep saying that. Take a look in the next video.